Hi, welcome to another tutorial for Quell, the discontinuous pillar in Python code for teaching and prototyping. In this tutorial, we'll implement a new initial condition and exact solution, specifically the cosine wave shown, to the 1D constant scalar vector class. In Quell, initial conditions are typically defined as classes. Our new class will be derived from an abstract base class called function base, which is used to define analytical expressions. The function base class is located in source/physics/base/data.py. Function base has one abstract method called getState. Our new class will be defined in functions.py in the scalar module. Before implementing this class, we first need to add another member to the function type enum class. So let's go ahead and do that and call it cosine. Now let's scroll down and implement the class right under the linear burgers class. In the init method is where we can define any parameters associated with the initial condition. Here, I'm going to create a parameter for the angular frequency, omega, with a default value of 2π. Then we implement the getState method where we prescribe the cosine wave. Now at this point, this is sufficient as an initial condition. If we also want it to be usable as an exact solution or a boundary condition function, we can take into account the time dependence. So let's do that now. C here is the advection velocity, which can be directly accessed from the physics object. The final step is to map it to the 1D constant advection scalar class. So let's go to the definition of that class in scalar.py in the scalar module. In the setMaps method, we add the cosine class to the IC function, exact function, and BC function maps. These maps tell the solver which function classes derived from the function base class can be used for initial conditions, exact functions, and/or boundary condition functions for a given physics class. More specifically, BC functions are the analytical expressions used for the state all BC.